Hello students, so today we are going to discuss about the flag transfer register. So first one is LAHF, that is load H with the low byte of the flag register. Then SAHF, that means store H register to low byte of the flag register. Then push F means copy flag register to top of the stack. Pop F means copy word at top of the stack to flag register. Next type of instruction is arithmetic instruction. These instructions are used to perform various mathematical operations like addition, subtraction, multiplication and division, etc. So first is addition instruction, add add, that means add specified byte to byte or word to word. Next one is ADC, that is add with carry. Next is INC, that is increment the specified byte or specified word by one. Next AAA, that means ASCII adjust after addition. Next DAA means decimal, that is BCD adjust after addition. Next is subtraction instruction. First is SUB sub, that means subtract byte from byte or word from word. Next SBB, that means subtract with borrow. Next DEC, that means decrement the specified byte or word by one. Next NEG, that means negate the invert each bit of a specified byte or word and add 1 or 2's complement. Then CMP, that means compare two specified byte or two specified words. Then AAS, that means ASCII adjust after subtraction. Next DAS, that means decimal adjust after subtraction. So these instructions are used to perform various. Then next is multiplication instruction. So first is MUL mul. So multiply unsigned byte by byte or unsigned word or word. Then IMUL means multiply signed by byte or signed. AAM means ASCII adjust after multiplication. Next, bit manipulation instruction. These instructions include logical, shift and rotate instruction in which a bit of the data is involved. Then logical instruction is first one is not, that means invert each bit of a byte or word. Next and, that means ending each bit in a byte or word with the corresponding bit in another byte or word. Next or means oring each bit in a byte or word with the corresponding bit in another byte or word. Next edger means exclusive or each bit in a byte or word with the corresponding bit in another byte or word. Next test, that means AND operation to update flag but don't change operands. Next one is shift instruction. So SHL or SAL, that means shift bits of a word or byte left, put 0 in LSB. Next SHR, shift bits of a word or byte right but put 0 in MSB. Next SAR, shift bits of a word or byte right, copy old MSB into new MSB. Next rotate instruction, it is ROL, rotate bits of byte or word left, that is MSB to LSB and to carry flag. Next ROR means rotate bits of byte of word right or LSB to MSB and to carry flag. Next RCR, that means rotate bits of byte or word right, LSB to CF and CF to MSB. Next one is RCL, so rotate bits of byte or word left, MSB to carry flag and carry flag to LSB. So next is string instruction. A string is a series of bytes or a series of words in sequential memory location. A string often consists of ASCII character codes. So first one is REP, that is repeat. An instruction prefix repeat following instruction until CX equals to 0. Then repeat equal or repeat 0. So repeat following instruction until CX equals to 0 or 0 flag equals to 1. Then repeat not equal or repeat not 0. It is repeat following instruction until Cx equals to 0 or 0 flag equals to 1. Then move S or move SB or move SW. That means move byte or word from one string to another. Next COMS, COMPSB, COMPSW. That means compare two string bytes or two string words. Then INS or INSB or INSW. That means input string byte or word from port. Next outs or outsb or outsw. That means output string byte or word to port. Next SCAS or SCSB or SCSW. That means scan a string, compare a string byte with a byte in L or a string word with a word in X. Then load S or load SB or load SW. That means load the string byte into L or string word into AX. So next is program execution transfer instruction. So these instructions are similar to branching or looping instruction. These instructions include conditional and unconditional jump or loop instruction. So unconditional transfer instruction is call a procedure, save return address on stack, then return from procedure to the main program, next JMP, go to specified address to get next instruction. So next is conditional transfer instruction. So first is JA or JNB, that means jump if above or jump if not below or equal. Next JAE or JNB, jump if above or jump if not below. Next JBE or JNA, that means jump if below or equal, jump if not above. JC means jump if carry flag is 1. JE or JZ means jump if equal or jump if 0 flag is 1. Then JZ or JNLE, jump if greater or jump if not less than or equal. JGE or JNL, that means jump if greater than or equal to, jump if not less than. Then JL or JNG, that means jump if less than or jump if not greater than or equal. Then JLE or JNG, that is jump if less than or equal or jump if not greater than. Then JNC means jump if no carry, that is carry flag is 0. Then JNE or JNZ, that means jump if not equal or jump if not 0, that is 0 flag equals to 0. Then JNO, jump if no overflow, that is overflow flag equals to 0. Then JNP or JPU, jump if not parity or jump if parity or, that is parity flag equals to 0. Then JNS means jump if not sign, that is sign flag equals to 0. Then JO means jump if overflow flag equals to 1. Then JP or JPE means jump if parity or jump if parity even, that is parity flag equals to 1. Then at last JS means jump if sign, that is sign flag is equals to 1. Next is iteration control instruction. These instructions are used to execute a series of instructions for certain number of times. So first is loop. Loop through a sequence of instruction until count Cx equals to 0. Second is loop E or loop Z, that is loop equal or loop 0. Loop through a sequence of instruction while 0 flag equals to 1 and the count equals to 0. Number 3 is loop, means loop not equal or loop not 0. So loop through a sequence of instruction while 0 flag equals to 0 and carry equals to 0. Next, JCXZ means jump to specified address if count equals to 0. So next is assembler directive. So assembler directive are the directions to the assembler which indicate how an operand or section of the program is to be processed. These are also called the pseudo operations which are not executable by the microprocessor. The various directives are explained below. First one is assume. The assume directive is used to inform the assembler the name of the logical segment it should use for a specified segment. For example, assume DS. That means data tells the assembler that for any program instruction which refers to the data segment, it should use the logical segment called data. Second is DB, that is defined byte. It is used to declare a byte variable or set aside one or more storage location of type byte in memory. For example, current value DB36H tells the assembler to reserve one byte of memory for a variable named current value and to put the value 36H in that memory location when the program is loaded into RAM. Then DW means defined var. It tells the assembler to define a variable of type var or to reserve storage locations of type var in memory. Next, DD means define double var. This directive is to use declare a variable of type double var or restore memory locations which can be accessed as type double var. Next is DQ, that is define quad var. This directive is used to tell the assembler to declare a variable 4 vars in length or to reserve 4 vars of storage in memory. Number 6 is DT, that is define 10 bytes. It is used to inform the assembler to define a variable which is 10 bytes in length or to reserve 10 bytes of storage in memory. Next, EQU means equate. It is used to give a name to some value or symbol. Every time the assembler finds the given name in the program, it will replace the name with value or symbol we have equated with the name. Then ORG means originate. The ORG statement changes the starting offset address of the data. It allows to set the location counter to a desired value at any point in the program. For example, the statement ORG3000H tells the assembler to set the location counter to 3000H. Then number 9 is PROC, that is procedure. It is used to identify the start of a procedure or subroutine. Then end program means this directive indicates the assembler, that is the end of the program module. The assembler ignores any statements after an end directive. Then ENDP means end procedure. It indicates the end of the procedure or subroutine to the assembler. Then ends, that is end segment. This directive is used with the name of the segment to indicate the end of that logical segment. Next, simple assembly language programming using 8086 instruction. So first one is write a program or read a character from the keyboard. The first is move age, 1H. So keyboard inputs a program. Then int 21H, that is character input. So character is stored in AL register. Then move C, AL means copy the character from AL to C. Next is write a program for reading and displaying a character. So move AH, 1H, that is keyboard input subprogram. So int 21H means read the character into AL register. So move DL, AL means copy the character to DL. Next, move H, 2S means character output subprogram. Next, int 21H, that means display the character in DL register. So this is all about the chapter 5, that is 8086 microprocessor. I think the video